All right, ladies and gentlemen, please welcome onto the podcast today Keith McCormick. He is an executive data scientist at Pandata and also a teacher for us at TDWI. He's going to be teaching a couple courses at TDWI Chicago coming up in April 28th through May 3rd. And the topic of those courses, as well as the topic of our discussion today, is going to be machine learning. But before we jump into that, Keith, welcome. Thank you so much for joining. How are you doing today?
Oh, I'm doing great. Thanks for the invite. I'm looking forward to this.
Me too. And this is the first time that we've had a chance to discuss, to have you on the podcast to discuss your expertise. And I think machine learning is going to be a great topic for our audience. But I would love to, if possible, Keith, can you give a brief background about yourself, your expertise, and how you ended up where you are today, before we jump into the actual machine learning side of things?
Sure. Like any career, it's had some twists and turns, but I think if you look back in retrospect, it kind of all makes sense. It's actually how my career started is actually why I moved to North Carolina, which is where I'm joining you from, my home here. I thought I was going to do graduate work in statistics because my first job was a statistics software trainer. Happened to be SPSS, which some folks are probably more familiar with. But I thought that was just going to be some extra work on the side while I worked through grad school. I was actually contemplating a topic that probably isn't on most people's short list, psychometrics, kind of a blend of
Wow.
psychology and statistics. So it's the kind of thing that people that work for organizations like Educational Testing Service, so that kind of thing, pursue. Because I just gotten very interested in that kind of stuff. So when SPSS asked me, they kind of found me because I was taking some advanced courses and including some of their programming courses. Not everybody associates programming with SPSS, but they do have a programming language behind the scenes. And they said, well, I think you'd be a good fit for our basic intro class because they thought it was kind of flattering that I was a good blend between the practical and the theoretical. And as you can guess, they don't always get that mix, right? They sometimes get
Right.
very academic person that maybe hasn't, spent time in the corporate realm, or vice versa, somebody that doesn't want to field audience questions about the concepts and the theory. So, I mean, little did I know that, now just about 30 years later, that that's still the topics that really attract me is this mix of theoretical and conceptual. So the quick version is that because machine learning and statistics are fairly closely related, SPSS bought a much smaller company that made one of the very first predictive analytics workbenches, something that we would now associate with well-known brands, like a Data Robot or an Alteryx or a Nine analytics platform. It was called Chromatine at the time. This will be a little test to see who knows their 90s software trivia that recognizes that name. But that's how I got involved in machine learning. And then as machine learning got hotter and hotter over the years, really steadily this whole time, we think of it as a recent thing, but it really has been growing steadily over the last 2 or 3 decades. There just became more demand for me to consult as well as train because there just weren't enough of us. So if a client needed specific help, so in a career like mine, it kind of starts as customized training, and then it becomes consulting, and then it becomes running consulting teams and the whole 9 yards. So the kind of topics that I present at TDWI really draw upon all of that field experience that I've had over the years leading projects.
Yeah, fantastic. And I always like to start with that question because I'm so curious how people end up in this field. And it tends to be kind of a meandering path is what I've found. Is very
Yeah.
few that I've interviewed are like direct. I mean, I had I guess recently it was like I was born to do this is what I wanted to do. But out of that, she was the 50, 60 episodes we've done. She's the only one that said that so far. So thanks for sharing your story on that. And I actually, you kind of led me to my first question nicely because I was curious about your perspective over these years, a couple decades that you've mentioned. What changes have you seen, starting back in the 90s and comparing them to more recently in machine learning?
Well, it's interesting because the word that you just suggested, meandering, is accurate in the sense that I've had a mix of full time and I've had a lot of contract work. In fact, it's really been the bulk of my work has been as kind of a solopreneur. But I've also worked directly for organizations like I do with Pandata. So that's changed, and I couldn't have foreseen exactly all the twists and turns, but the topics are remarkably similar. So, for instance, I've seen statistics go from such a high priority that as a 20-something years ago, I thought that I had to get a PhD in a statistics related field to be taken seriously. And now I don't think any 20-something would think that a stats PhD, in fact, they probably would be horrified at the thought, would be what they would need for machine learning or AI. They would see it as such a disparate discipline. But looking back, I can see the continuity. I mean, the statistics that I you know, knew pretty well, but got much, much better at teaching thousands of people, with all that SPSS training has served me really well. And it's still, one of the topics that I think all data scientists have to have some familiarity with, even though they're almost certainly not going to pursue graduate work in statistics. It's still an important skill set. So I've seen more continuity than I've seen the meandering, even though if I talked about all the organizations I've been affiliated with, it would seem meandering. I've detected a lot of continuity there. So when I sit down with clients, it's one of the things that I first point out to them that I think they need to know that, let's calm down a little bit. We've got all these new topics and they're exciting and that's important, but folks have been doing lead scoring, like marketing leads and fraud detection and anomaly detection and preventive maintenance, not just for years, but for decades, and that continuity is important because you don't have to reinvent the wheel and you don't have to reconceptualize these problems just because you want to show off to your friends with the latest techniques. There are established solutions to some of these famous case studies or I guess use cases would be the phrase that people would use.
Sure. Yeah. Case study, use case,
Yeah.
semantics, right? But okay. So obviously, I'm sure in more recent years, there's been, maybe some more attention drawn to this. And that's probably why people think it's new as opposed to like, the same thing with artificial intelligence, machine learning, whatever words you'd like to use. So I'm curious, what should organizations know about topics like deep learning and large language models? And how do they identify the practical applications of these techniques that will work for them?
Well, I think that's an important question because I think everybody senses that we're going through something new. So, even though I can look back over all these years and see some continuity, there clearly is something going on that has got everybody's attention. And it's not just hype. So how do you separate what can be a little bit dramatic, in maybe our LinkedIn feeds or blogs or that we read or podcasts that we listen to, where's all the reality in there? Well, one of the things that I actually get a chance to talk about in the courses is how important some of the events in 2012 were. That's when there was this big event called the ImageNet competition. Well, that wasn't the only year. It was the third year of it. But anyway, it's when deep learning won the ImageNet competition. It's a long story, so I won't get into it now. But it was a really big deal because it's when deep learning really thoroughly beat the previous techniques in computer vision. Specifically, is that a chair, or is it a bicycle, or is it a cat, or is it a dog, or is it a hot dog? For instance, I'm not sure how important the hot dog was to ImageNet, but it's certainly important in pop culture that you can correctly identify hot dogs, right? So a little bit of this history goes a long way, I think, both with folks that I meet in a conference setting and when I'm talking to clients about their problems, because what does happen when you have this level of excitement is that folks will approach you and say, my boss has asked me to find a way to use large language models in our organization. We don't know what we want to do, but our boss really wants us to do something. Well, that's not how you're supposed to start the conversation. You're supposed to start the conversation with, we have problem X. Keith, given your experience, what would be the best way to tackle problem X? And indeed, it might be something like a large language model, right? But you got to start with the problem. You can't start with, wow, we really wish we had a use case for large language models because everybody seemingly is using them and we don't want to be left behind, right? I mean, you can see why people start a conversation that way, but it doesn't really make a lot of sense. So the quick version is that deep learning has made these enormous strides in applications like voice, like speech to text, chatbot. I was just glancing to see if I have one of those devices on my desk that's going to start talking to me, and I don't at the moment. Um, so that's a big one. Image and video. And you might think, oh, video, who needs video? Well, drone delivery is right around the corner, probably. We're going to be getting takeout food dropped lower down on our back porches, right? That's not 20 years away. I mean, I'm not one of these industry experts that tries to say, is it 3 years or 5 years or what have you, but not far from me in
Right.
Raleigh-Durham, there is an area that's already doing it, right? So it's not that I think it's like 1 square mile or something that they've done because Raleigh-Durham seems to be one of those places that has the right demographic mix that they roll out certain things. I grew up in Rhode Island, actually, and for whatever reason, Rhode Island tends to be another one where they
Oh,
test market things, where the mix of demographics is whatever the marketers thinks it needs to be to make for a good test market. So audio, as I mentioned, image, video, and natural language processing, right? So it's not a surprise that after 2012, that was going to be an area that was going to get a lot of attention. And then something actually that I was just reading up on over the weekend is that in 2017 is when the articles on transformers was written. And all this is a bit technical, so it's not the kind of thing that I get into in an introductory course, but that's what the T in GPT stands for, is transformers. So that was like a big moment too. But what all of these have in common, it's very simple to remember, is that it's all unstructured data. It's pixels, it's sound waves, it's all that kind of stuff. So the stuff that I've been doing since the 90s is all structured. It's 1 row per insurance claim. It's 1 row per customer. But that hasn't gone away. That still exists. So that's why I sometimes sit down with a client and conclude that old school, or what I call traditional machine learning techniques, absolutely fit the bill. And why, if I'm talking to somebody about, security at a museum, or drone delivery, as I mentioned earlier, or, oh, there's another interesting one, drone inspection, flying a drone under a bridge, or something like that. Those are not, that's not structured data. How are you going to get the information that it's going to take to fly under a bridge to see where a crack might be? How does that fit in your Excel spreadsheet? It totally doesn't. We're talking video that has to be annotated and all that kind of stuff. So the applications are real, but I think it's fair to say that there's probably more organizations out there that should be focused on their structured data, and relatively few, as a percentage, where they're going to meet the criteria that I just described. But nonetheless, we're heading in a direction where everybody's going to have a mix of use cases, and it's probably going to be in different teams, to be honest. I mean, it's, just like we have BI and data science, there's going to be a day in the not too distant future where we have an AI team and a traditional machine learning team, and they're going to have to come up with some better name than traditional machine learning, because nobody will think that's sexy enough.
Yeah, no, I think some of those use cases that you just mentioned are the fun part about this new wave of, LLMs and machine learning and generative AI, all this fun stuff that we're talking about. But I do think a lot of times, they're putting the cart before the horse, to bring up, a very common phrase. And so many times I hear about, these problems that organizations are facing start way back with, the data quality, right? Like, you start from the
Yeah.
from the very beginning, before they can actually go ahead and say, oh, actually, we need a large language model for some reason. But I can totally see why, especially CEOs are like, well, we need some sort of artificial intelligence, large language model. We need machine learning in this organization to justify that we're on the cutting edge. But that's not always the case. I'm glad you made that distinction. I'm curious though, because as we get into generative AI and large language model, machine learning, there is a concept that's been talked about a lot as far as responsible AI, and I know that you've mentioned this as well. What do you think we should know on that topic, and how does that necessarily relate to some of this that some of these things that you just brought up, as far as those use cases? We're using drones for footage or anything else for that matter.
Well, one, I agree that it's important, so I'm glad that we're talking about this. But I'd also say it's not unrelated to what we were just talking about, as you hinted at, because these newer techniques produce pretty complicated, models. And responsible AI is a lot of things. Certainly, there's ethics involved. Um, what we talk about most often, and I don't want to diminish its importance, but I think it's the part of the story that most people have already heard, is the potential for bias. Whether you're talking about favorable rates on a mortgage, or favorable rates on an insurance policy. Recidivism is a really big one, that people talk about. Super important topic, but I think most people have read quite a bit about that aspect of it. I think most fundamental to responsible AI is model transparency. Because if the model's opaque, these so-called black box models, you really can't do any of that stuff, including the avoidance of bias that I was just discussing. But there's other problems with a lack of transparency. Um, it's hard to know when the models make mistakes, why they're making mistakes. So an aspect of this that certainly people have read a ton about in the press is that when large language models hallucinate is kind of the new word that we use for this. Their own version of making mistakes that folks don't know why. Some of the most interesting thought leaders in the space will say that we really don't fully understand how the really big foundation models work. So when I'm working with consulting clients, certainly my colleagues at Pandata and I feel strongly about this, we seek that transparency even when it's not required. And what I mean by required, we think that we're kind of ethically bound to seek that transparency. But by required, I mean in healthcare, it might be a condition of the project is the model has to be transparent. But we're often talking to clients that don't have some regulation that's forcing them to have model transparency, to think about what that model transparency is. So there's a technical aspect of this that I don't want to go down that rabbit hole, but I think it's worth mentioning. There is a set of techniques called explainable AI, where you can try to pull out of the model reasons why a particular prediction was made. When folks apply maybe for a refi their mortgage at a more favorable rate or something like that. And we've all gotten those letters at some point and often they'll actually have a code next to them, right? Oh no, we can't offer you the VIP rate, but we appreciate you as a customer or whatever. And then next thing you know, you get this letter and say, oh, you filled out this form and all that kind of stuff. So it might say, one of the reasons was code 87, whatever that is. And you can actually go to a website and look that up. That's an example of explainable AI that's been around for a long time, where you can either trying to describe the entire model, or what's called a local explanation is what I was just describing, where you can say, oh, that particular denial was for this code, and then you can look up the code, right? So just within the last 5 years, it really has been that recent, there's been an explosion in these explainable AI techniques. And you can guess why. 2012, deep learning took off. Deep learning is always opaque. The use of deep learning spreading. So right behind it, it's like deep learning is the engine and explainable AI is the caboose. It's getting pulled right along. You have this increased number of folks that need these explanations because they're building complex models. So one way or another, if you're going to do, what we call responsible AI, and there's actually nonprofits that are trying to put together self-enforced rules at this point on that kind of thing. But the EU, is, in fact, I think it's just passed or it's further along in being passed. It's just a matter of time before there's more regulations around that. So you can use these traditional models that are kind of inherently transparent, or you can use these fancy ones. So that ended up being a little mini little tiny lecture on explainable AI, but it's one of the topics that is in my kind of repertoire, I guess you could say, that we cover at TDWI, because it can be a very helpful supplement to these black box techniques.
Well, yeah, that I'm so interested in that now, and I haven't really had the chance to discuss that with anyone on this podcast. So I'm so glad that you brought it up because that was the big concern, at least when when we were first talking about foundation models and initially some people were trying to build their own, right? Like maybe a company was going to just spend the resources and the time and all that and try and make their own large language model, foundation model. Is how do you have a mechanic go, for lack of a better term, mechanic open up the hood and see what's happening? And it sounds like there has actually been some serious advancements in that space, which is fantastic. I know that EU and other, we're gonna have a whole litany of legislation
Yeah.
globally from every country about how they're gonna, try to handle this. But it's great to know that those people out there are very much expanding that side of the things and making it more opaque, making it more, transparent, as you just stated there. So that's great
Yeah,
news.
it's remarkable when you think about it, right? I mean, I've been teaching for TDWI, and also I like to arrive early and late so I can attend the other instructors. I always enjoy that. Sometimes I have time to either speak at or attend the leadership conference as well, which I'm sure you're familiar with. A lot of folks that are listening possibly are, but they often are co-located. But anyway, the reason I'm bringing this up is even during the time that I've been speaking at TDWI events, which is I think like eight years, but it's certainly not more than 10, right? The techniques that I talk about in my half-day explainable AI, of course, didn't exist 10 years ago. It's really remarkable. I mean, a lot of the techniques that I talk about go back to the 80s. I mean, regression's been around for well over 100 years.
Yeah.
But these explainable AI techniques really have grown in popularity because of the rise of these complex models.
Which is fantastic. I mean, and it makes all the sense in the world that it would be happening, right? Like you
Yep.
need that explainability, you need that lineage, and I think I've heard now that there's going to be some version of auditing that's going to be happening in the same way that our tax returns are audited. Maybe not in the exact same way, but some version of that's going to be happening for these organizations. So they have to have, in some instances, this explainability, this lineage to go back and say, oh, this is what we did, this is how it went. So all of that's very interesting to me. But I do want to ask, I know we're running out of time a little bit here, Keith.
Hmm.
If you had some advice, a lot of our audience members are, still in schooling or they're just starting out on their career here in the industry. If you had some advice for aspiring data scientists in regards to this machine learning side, what would that be?
Well, in the spirit of time, but also because this is the way I almost always answer it. There's about two or three that immediately come to mind, right? And I think that a lot of newly minted data scientists, or maybe folks that are thinking about a career change, might be surprised by this list because they're not going to be the most recent three things. They're going to be what I think to be the most like foundational things. Really understanding linear regression is one. And I know that sounds so old school, but I think if you don't really understand linear regression, I mean, thoroughly understand it, you can't truly understand what neural nets do and why neural nets are able to kind of seemingly without a lot of human help figure out things, right? And that might surprise people at folks again. And then, but anyway, that's one. And then decision trees is another. Probably also sounds, a bit mundane or old school. It's one of the topics actually that I teach fairly often at TDWI events. And it's because, one, they're still useful in their own right. And even if someone's skeptical about that, I say, oh, Keith, I really want to use something a little bit fancier. I mean, gosh, I want to beef up my portfolio and I want to show people what I can do. Even if you don't buy the premise that you're going to use the decision tree all by itself, I would try to talk them out of that. But even if they felt that way, you can't understand random forest and XGBoost, which are two of the most powerful contemporary algorithms out there, without understanding decision trees. So sometimes that's the way that I end up presenting it too, where I walk people through decision trees and then teach them ensembles, which is this idea of having more than one model. And if people have never heard of random forest before, they might be able to guess that it's a bunch of trees. And, there's a little bit of technique in doing that. And then finally, there's a topic that I think doesn't get enough attention is really knowing the machine learning life cycle. So I'm a big fan of a published one called the Cross Industry Standard Process for Data Mining, CRISP-DM. that actually a lot of folks, not just me, talk about. But the reason I think that's so important is that even if you're alone on a team, you've got to manage the project, you know? And certainly if you're running a team and there's 2 or 3 data scientists working together, you got to have some kind of structure to how you go through this journey. So regression, decision trees, and the machine learning life cycle are my top 3.
That's fantastic. And you did mention that I know for a fact one of the courses that you will be teaching in Chicago is around the decision tree. Would you just take us through I know you have, it's like 2 half-day courses and a full-day course. Can you just go through those for us quickly without,
Oh, sure, sure, sure.
expounding too much on that for us?
So yeah, and thanks for the reminder that that's the lineup in Chicago. It's going to be decision trees in the morning in a half-day session, and then ensembles, which gets into really the whole idea of an ensemble, because you're not restricted only to random forest and XGBoost, but then it gets there. And then I mentioned the XAI stuff a little bit, but we don't have time in that agenda to talk about that in detail. But that's the basic idea. So that way, there are some folks that maybe are practicing data scientists that feel that they can just come to the afternoon, which they're welcome to do. And there might be some folks that are brand new at the technique that just come in the morning. But most folks attend both half days, and it's a really fun, nice journey going through, those 2 topics.
All right,
And then
terrific.
I think in Chicago, I'm teaching unsupervised, which is cluster analysis, association rules, marketing segmentation, basically. I'm sure folks are familiar with association rules. That's like, if you like this book, you'll also like that book. If you enjoyed this movie, you'll also enjoy that movie, that kind of thing. Yeah. So you can summarize it by saying I'm doing a day of supervised and a day of unsupervised. And briefly, I'll mention too that a great feature of these events is people can sign up for office hours, they're called. So I think I'm teaching in the second half of the week in Chicago, but I'll get there at least a day early. So any folks that happen to hear this before the Chicago event, if you're coming to Chicago, check out the office hours. It's available to any attendees, and it's just really fabulous. You just schedule a half hour, and we just chat. You just ask me questions, and I answer as best I can in a half hour, and then I try to do a few of those, typically on my non-teaching day. So seek me out.
Yeah, that is actually a great thing that we offer at all of our conferences. And I know some of our attendees have been able to take advantage. Some don't know that it's there, but for those that aren't aware that are going to attend, please utilize it. It's fantastic. You can have that one-on-one connection and conversation with an instructor like Keith. All right, so I know I got one last question for you, Keith, before I let
Sure.
you go here. What are you currently working on that folks might find interesting and maybe related to machine learning or AI?
Well, there's a couple of things. So let me think. One is that I'm actually working on a new half-day course that I'm sure, in fact, I'm quite certain I'm going to be presenting at TDWI at some point soon. That really gets into the AI piece that we were talking about just a little bit, like what are the use cases associated with deep learning? But it won't just be, I'm sure I'm going to recap a little bit of that history with my audience when I present that, but it won't be only that. It will then be basically trying to pair specific use cases with techniques, and give folks a little bit of idea, hopefully, so that they can spot opportunities at work where deep learning is the way to go, and then identify which techniques to start to think about for that. So I'm really looking forward to that, because it's it's a new topic, and I think it's time. People need to really know how to navigate that. And I've got a book coming out later in the year that I'm excited about. It's more for university audience, I think, than probably the folks that are watching this today. But I was invited to participate in the 3rd edition of what I still think of as the data mining handbook. That's not the full name, but with my co-authors Bob Nisbet and Gary Miner. And it's a big text, but it's been a popular university text. And what was interesting about doing a 3rd edition, because doing revisions is usually not especially interesting, was saying, what's all this stuff that's new that didn't exist when the 2nd edition that came out that needs to be in this topic? Yeah, so that was kind of an interesting journey, but books like that take forever. So already a year into that project, and it won't be printed and on shelves for another 6 months. But that, that's been on my mind.
That was terrific, Keith. Thank you so much for your time today. I'm going to ask one final question. If someone watches or listens to this episode and they're interested in reaching out, maybe they can't make it to Chicago in person, is there a good way for them to get in touch with you?
Sure, I would urge them to follow me on LinkedIn.
All right, terrific. And for those folks that are able to attend, I'll just remind you, this is our Transform 2024 TDWI event in Chicago, taking place April 28th through May 3rd. I will go ahead and put a link to the description of Keith's courses in this episode, as well as a link to the full agenda. Would encourage everyone to go ahead and check that out. It's going to be a fantastic event. And Keith, very honored to have you with us again for another event. And unfortunately, I won't be there to meet you, but maybe sometime down the road we might be able to, I don't know, have a drink, shake some hands, and chit chat a little bit about what's next in that textbook for you, and in that new course that you're going to be potentially releasing as well. I'm excited about that. But thanks so much for your time, Keith. Really appreciate
Yeah,
it.
I would enjoy that very much. I hope that happens. Yeah, thanks again. Take care.
Alrighty. To subscribe to the Speaking of Data podcast, or to learn more about TDWI's research and training on all things data management and analytics, visit tdwi.org or click the link in the description below. Thanks for tuning in.